The American National Standards Institute C84.1-2016 specifies the performance requirements for electrical power systems and equipment, including voltage limit. The National Electrical Code provides guidelines for electrical installations, including voltage requirements. For a 120 volts AC system, under ANSI C84.1-2016, the nominal voltage is 120 volts. The normal operating voltage is 114 volts to 126 volts. The extreme voltage is 110 volts to 132 volts. The National Electrical Code specifies a normal operating voltage of 114 volts to 126 volts according to Article 210.19. A plus 10% voltage tolerance for a 120 volts AC system would be calculated as follows. Firstly, the minimum voltage is 120 volts minus 10%, which equals 108 volts. Secondly, the maximum voltage is 120 volts plus 10%, which equals 132 volts. This voltage range is within the ANSI C84.1-2016 and National Electrical Code specifications for a 120 volts AC system. Therefore, it can be considered acceptable. Voltage fluctuations can occur due to various factors such as load changes, power outages, and equipment failures. Equipment should be designed to handle voltage variations within the specified limits. Exceeding the voltage limits can lead to equipment damage or safety hazards. It is recommended to monitor voltage levels to ensure compliance and avoid potential issues. The normal voltage range that electrical distribution systems should provide to the customer is 114 volts to 126 volts. The utilization voltage range is 110 volts to 126 volts. It is worth noting that ANSI C84.1 defines specific voltage ranges for different types of systems and equipment. These ranges are intended to ensure that equipment operates safely and efficiently. The standard also provides guidance on how to deal with voltage variations and other power quality issues. In addition to ANSI C84.1, the National Electrical Code also contains requirements related to voltage. Article 210.19 of the National Electrical Code specifies the minimum size of branch circuit conductors based on the ampacity of the circuit. The article also includes a table that provides voltage drop information for different conductor sizes and lengths. This information can be used to ensure that the voltage at the load is within acceptable limits. Voltage drop is the reduction in voltage that occurs as electricity flows through a conductor. Voltage drop is caused by the resistance of the conductor to the flow of electricity. The amount of voltage drop depends on the length of the conductor, the size of the conductor, and the amount of current flowing through the conductor. Excessive voltage drop can cause equipment to malfunction or fail. It can also lead to increased energy consumption. For these reasons, it is important to ensure that voltage drop is within acceptable limits. There are several things that can be done to minimize voltage drop. Firstly, use conductors that are large enough to carry the load. Secondly, keep conductor lengths as short as possible. Thirdly, use conductors with low resistance. Fourthly, balance the load on each phase of the electrical system. Another important consideration is voltage unbalance. Voltage unbalance occurs when the voltages on the three phases of a three-phase electrical system are not equal. Voltage unbalance can be caused by a variety of factors such as unbalanced loads, faulty equipment, and poor wiring practices. Voltage unbalance can cause equipment to overheat and fail. It can also lead to increased energy consumption. For these reasons, it is important to minimize voltage unbalance. There are several things that can be done to minimize voltage unbalance. Firstly, balance the load on each phase of the electrical system. Secondly, use equipment that is designed to operate with unbalanced voltages. Thirdly, correct any wiring problems that may be contributing to voltage unbalance. In addition to voltage limits and voltage drop, there are other power quality issues that could affect the performance of electrical equipment. These issues include harmonic distortion, transients, and voltage sags. Harmonic distortion is the presence of harmonic frequencies in the electrical system. Harmonic frequencies are multiples of the fundamental frequency of the electrical system, which is typically 60 Hz. Harmonic distortion can be caused by a variety of factors, such as nonlinear loads, electronic equipment, and adjustable speed drives. Harmonic distortion can cause equipment to overheat and fail. It can also lead to increased energy consumption. For these reasons, it is important to minimize harmonic distortion. There are several things that can be done to minimize harmonic distortion. Firstly, use equipment that is designed to minimize harmonic distortion. Secondly, install harmonic filters to remove harmonic frequencies from the electrical system. Thirdly, correct any wiring problems that may be contributing to harmonic distortion. Transients are short-duration voltage or current surges in the electrical system. Transients can be caused by a variety of factors, such as lightning strikes, switching operations, and equipment failures. Transients can damage sensitive electronic equipment. For this reason, it is important to protect equipment from transients. There are several things that can be done to protect equipment from transients. Firstly, install surge protective devices at the service entrance and at sensitive equipment locations. Secondly, use shielded cables to reduce the amount of noise that is coupled into the electrical system. Thirdly, ground equipment properly to provide a low impedance path for transient currents. Voltage sags are short-duration voltage reductions in the electrical system. Voltage sags can be caused by a variety of factors, such as motor starting, equipment failures, and utility switching operations. Voltage sags can cause equipment to malfunction or shut down. For this reason, it is important to protect equipment from voltage sags. There are several things that can be done to protect equipment from voltage sags. Firstly, install uninterruptible power supplies to provide backup power during voltage sags. Secondly, use constant voltage transformers to regulate the voltage supplied to sensitive equipment. Thirdly, improve the power quality of the electrical system to reduce the frequency and severity of voltage sags. Maintaining proper voltage levels is critical for the safe and efficient operation of electrical equipment. By understanding the voltage limits specified in ANSI C84.1 and the National Electrical Code, and by taking steps to minimize voltage drop, voltage imbalance, harmonic distortion, transients, and voltage sags, it is possible to ensure that equipment operates reliably and efficiently. It's also vital to consider the specific requirements of the equipment being used. Some devices may be more sensitive to voltage variations than others. The manufacturer's specification should always be consulted to determine the acceptable voltage range for a particular piece of equipment. Furthermore, regular monitoring of voltage levels is essential for identifying and addressing potential problems before they cause equipment damage or safety hazards. This can be done using a variety of tools, such as voltmeters, power quality analyzers, and permanently installed monitoring systems. When investigating voltage problems, it's important to consider all possible causes. This includes the utility power supply, the building's electrical system, and the equipment being used. A systematic approach to troubleshooting can help to identify the root cause of the problem and implement effective solutions. In some cases, it may be necessary to consult with a qualified electrician or electrical engineer to resolve complex voltage problems. These professionals have the knowledge and experience to diagnose and repair electrical systems safely and effectively. Alternately, ensuring proper voltage levels is a shared responsibility. Utility companies, electrical contractors, equipment manufacturers, and building owners all have a role to play in maintaining a safe and reliable electrical system. By working together, it is possible to minimize voltage problems and protect equipment from damage. Remember that local codes and regulations may impose additional requirements related to voltage. It's important to be aware of and comply with all applicable codes and regulations to ensure the safety of people and property. Also, note that while a plus 10% voltage tolerance might be acceptable under certain standards, it is always best to aim for voltage levels that are as close as possible to the nominal voltage. This will help to maximize the lifespan and performance of electrical equipment. If voltage levels are consistently outside of the acceptable range, it's important to take corrective action to bring them back into compliance. This may involve upgrading the electrical system, adjusting equipment settings, or working with the utility company to improve the power supply. Ignoring voltage problems can lead to serious consequences, including equipment failure, fire hazards, and electrical shock. Therefore, it's important to take all necessary steps to ensure that voltage levels are within acceptable limits. In conclusion, understanding and managing voltage levels is a critical aspect of electrical safety and efficiency. By adhering to relevant standards, monitoring voltage levels, and addressing potential problems promptly, it is possible to maintain a reliable electrical system and protect equipment from damage. Remember to always consult with qualified professionals when dealing with electrical issues.